minus by FADX is equal to 0. Okay. So that will be equal to FAB cos 60 minus by FAD cos 45, and the whole thing will be equal to 0. Okay. So cos 60 is equal to 0.5 FAB minus by cos 45, 0.707 FAD. The whole thing is equal to 0. So we can find out that FAD is equal to 0.5 FAB divided by 0.707. So we happen to find the relationship between FAD and FAB. So this is equal to 0.707, and this is our FAB. Equation number 2. Okay. So from here, I'll pause for a bit so you can, or I'll become a tree hugger. So we are going to substitute equation 2 into equation 1. Okay, let me know if I make a mistake, okay? So we have 0.866 FAB minus by 0.707, and then we have another bracket. We have 0.707 FAB minus by FAC is equal to 0. Okay. Yes. Yes. Okay. You try it. Pali. In Korean means pali. No. Don't stop whatever professor say. Good. Next time you are later, try to take one. Always have doubt. Are we clear? One of my best PhD students is killing me. Why? She always has doubt. And it always works. Okay, don't take it for granted. Unfortunately, Donald Trump is coming back. Even worse, don't take it for granted. That clown. So from here, FAB is equal to FAB is equal to what? 0.707 times by 0.707. 0.866 minus here, 0.3661. Okay, so it's equal to AY, not AY, FAC divided by 0.366. Okay, so 1 divided by 0.366 is equal to 2.732 FAC. Okay, 3.732 FAC. So now we have done what we can. We know, okay, that's all we can do for now. So this is very straightforward static analysis, and I hope you all were I think this is the important part, okay, that you all need to really like be very comfortable with the analysis, okay. There will be a question on 6th of February on something like this, very similar. Are we clear? Okay, so you have to be very clear about your what? Method of joint analysis, okay? Right, so from here, we are going to apply extended Euler's formula. Okay, that states that the critical load is equal to pi squared EI over LE squared. Okay, and another thing to take note is the factor of safety is equal to the critical load divided by the applied load. Okay, so PCR or P is the applied load. Okay, is the applied load. So knowing that our structure, so if we go back to our structure, our question, okay, so let's see what we know, okay? We know pi squared, we know E, we don't know our I, and we don't know our LE yet, okay? Don't know yet. So the next thing we're going to do is we're going to determine I, okay? So given that our structure has a diameter of structure has a diameter of 50 millimeters for member AB, okay, of structure. Okay. So the formula for second moment of area for I is equal to pi over 4 multiplied by R4, okay? So this formula will be provided. Don't expect you to memorize. So pi over 4 multiplied by, so that's a diameter, radius will be 25 to the power of 4. So pi over 4 times by 25 power 4 is equal to 306.796 times 10 to the power minus 3, positive 3 millimeter 4. So if you want to change to meters, you just plus by minus 12. So this will be equal to 306.796 times 10 to the power minus 9 meter 4. Okay. So the next thing we have to do is we have to determine the LE. Okay, determine the LE. So for this case, if we look at this structure, right? And if this is our X, Y plane, and this is our rotation about Z, and you already have seen, right, the example that we talk about over here, right? And we know that LE is equal to L, so it's going to be pin. In the other rotation, LE will be what? Higher. Okay. So this question, being oversimplified, it did not tell us. Okay, it just say this is what it is. Okay. But as engineer in real life, when you later see some more complex problem, you have to be aware of dissolved analysis. Are we clear? Okay, for this case, the question is not very specific, it's very simple. So we are going to assume that buckling, okay, so you have to declare that buckling is going to occur in the XY plane. Okay, so you make the assumption. So from here, any question with the assumption? Okay, we just, yes. So this is the plane that we're looking at, right? So this is XY plane that we're viewing at. So buckling will occur in this direction. So from here, we know both ends are what? Are pinned. So when both ends are pinned, going back to the previous lecture, and this diagram will be given if both ends are pinned, right? So for this case, both ends are pinned. Again, this diagram will be provided. So we know that both ends are pinned, right? So when both ends are pinned, comma, LE is equal to L, and the length of the beam is equal to 4 meters. Okay, the length of the beam is equal to what? 4 meters. So from here, we calculate the critical load. The critical load now is equal to pi squared multiplied by the Young's modulus of 200 times 10 to the power 9 multiplied by I, which we calculate is 306.796 times 10 to the power minus 9 and divide by the equivalent length. So the equivalent length is equal to 4 squared. So this will be equal to 37. Let me try, is it 37? So shift pi squared times by 200 power 9 times by 306.796 power minus 9 divided by 4 divided by 4. 37.849 times 10 to the power 3. And this is our Newton. So now we have to determine what is our P. Okay. So this critical load, this PCR over here, is dependent on length. Okay, it's dependent on the length, second moment of area, and Young's modulus. And fixturing. Fixturing is how both ends are what? Are fixed. Okay, so that is the extended Euler's formula. Okay, so from here, we know that factor of safety is equal to PCR divided by what? Divided by P. Okay, so now we know that the factor of safety given is 2.0. We calculate our PCR, which is equal to 37.849 times 10 to the power 3. Then we divide by P. Okay, so therefore P is equal to 37.849 power 3 divided by 2. So this is equal to 37.849 power 3, power 3 divided by 2 is equal to 18.925 times 10 to the power 3 Newton. Okay, so that is our P. So now we know our P value, right? So our P value, not P, over here is also equal to our what? Is also equal to our P. So P over here is equal to our FAB. Okay, P is also equal to our FAB. So FAB is equal to what? FAB is equal to 2.732 FAC. 2.732 FAC. Okay. So where we get this relationship? We get this relationship from here. Can you all see that? We have calculated that out. So from here, we know that P is equal to 18.925 times 10 to the power 3. This is equal to 2.732 FAC. So therefore, FAC is equal to 18.925 power 3 divided by 2.732. So the answer is 18.925 power 3 divided by 2.732. Eugene, come on. 6, 9, 2, 7.2 Newton. Okay, so I want you all to round it off to 6,927 Newton. Okay, in terms of Newton, forget about what? The decimal point. Are we clear? Okay, what is 0.9 of a Newton?